All right, everybody. So we're going to talk about rigid transformations today. And the big thing to start off with is just kind of getting a little summary about some parallel and perpendicular lines. So, of course, parallel meaning the fact that two lines never intersect. And the big thing to know about this is that the slopes are the same. And so when you would take a look in an Algebra 1 class, right, you have y equals mx plus b for your lines. Well, that m would always be the same for both lines. So I could have an equation of y equals 2x plus 3 and y equals 2x minus 3, and those two would be the same slope, and so that they would be parallel. And the next thing is perpendicular lines that will help us out today. And so perpendicular is like an upside down capital T with a nice little right angle marking to show that. And then kind of the cool thing about perpendicular lines is the fact that there's these slopes called opposite reciprocals. Opposite reciprocals. And the cool thing about opposite reciprocals is the fact that essentially if I have a slope of, let's say, 3 over 4, and so that's a positive slope, kind of, that would look like this, not necessarily going up 1 over 1. And then my opposite reciprocal would be negative 4/3. And so now all of a sudden I am going down more than 1. I'm going down 4 and then over 3. So again, it's not a 1-to-1 type of relationship. But notice what happened here, right? I essentially flipped my numerator and my denominator, and then I added this change of sign. So I went from a positive to a negative. And you'll notice that the blue line there, again, has a negative slope. And so those are, for perpendicular lines, we have opposite reciprocal slopes. And so that's the main thing to take away from that. So moving on then, we have rigid transformations. Rigid transformations. And you'll notice that we have 3 of them: reflections, rotations, and translations. Reflections, you're looking in the mirror. Essentially, it is going to be a mirror image of the given image. It's essentially like we flip it. These are other words that we use. We essentially flip it. Rotations is a nice turn that we'll do to the shape about a point. Typically, it's the origin, particularly in this class beginning wise, but we'll spin it around a point. And then translations is essentially a slide. As a slide. So for reflections, if I have a shape that looks like this, and we'll call it triangle ABC, the reflection of triangle ABC across essentially what's the y-axis here, I take my point and I go in the same distance to the line of reflection, and then I move the same distance out. And we're going to call this point C prime. So it's a new point, but it's based on that original point C. And so similarly, I'm going to kind of go through here. And while this is not an exact science on this sketch, it should be pretty close. So once you get some graph paper, it's a bit nicer. But you hopefully kind of get the gist here. And so we have a reflection across the y-axis. The good news is no matter if it's a horizontal line, no matter if it's a line with a slope, we will always go in at a right angle. We always want the line of reflection to be at a right angle. So if I'm taking this point D and I want to reflect it somewhere over in this area, I'd be going in, let's 1, 2, so to speak, and out 1, 2. And that would be then D double prime, because I just named that D prime. So that type of a deal. Always in at a right angle. For rotations. So if we have a shape, we want to rotate it about a, let's move it about point C here. And I'm going to move it 90 degrees clockwise. So oftentimes you'll kind of see this notation right here of how we're spinning it. It's either like that or going counterclockwise would look like this. So rotating it clockwise, I then would have an image that looks like this. And B is essentially going to come down. And so this would be B prime. A prime would come across. And then I would have D prime in the top left corner. Again, if I'm rotating at 90 degrees. C, since it's already there, I don't really need to do it. But could I? Yes, and label that C prime. Translations are, in my opinion, the easiest. But maybe not for you. We'll see here. But it's a nice little slide. And so if I have a triangle here, and I am told that I am moving this, let's say 3 down and 2 to the right. Well, then I would take each point. I would go 1, 2, 3 over 2, 1, 2, 3 over 2, 1, 2, 3 over 2. And so you'll see the fact that here in blue, I now have my E prime, F prime, and G prime. And so that would be, again, a translation. So oftentimes it's talked about in terms like 3, 5 up, 2 to the left, whatever that might be, kind of going through there. Okay? And the last part of this video is going to be some shape definitions. So a quadrilateral is a shape with 4 sides. A parallelogram is a quadrilateral with 2 sets of parallel sides. A rhombus is a quadrilateral with 4 congruent sides. And the congruent sides essentially means equal. It's kind of a synonym that you'll take a look at in this course. A rectangle is a quadrilateral with 4 right angles. A square is the marriage between a rhombus and a rectangle. So a square is a quadrilateral with 4 right angles and 4 congruent sides. And finally, a trapezoid. A trapezoid is a quadrilateral with 1 set of parallel lines. And so those are your shape definitions that you'll be using in this chapter as well. Hopefully this helps. Thank you.